All right, this is the video solution guide to the first page in your nomenclature packet. All of these are going to be binary ionic type 1, so meaning binary, two elements, a metal and a nonmetal. That's the ionic part. And then type 1 meaning all of the metals have one charge, a fixed charge. Okay, so first one, all you do is name the metal, name the nonmetal, change the ending to "ide." So this is aluminum oxide. Okay, this one, CS is cesium, and then oxygen becomes oxide. This one is rubidium, nitrogen becomes nitride, rubidium nitride. Okay, this one would be calcium nitride. Notice we don't have to mention the numbers on any of these. It's just name the metal, name the nonmetal. SRSE would be strontium. Selenium would be selenide. Cesium, sulfide. Oops, skipped one there. Aluminum sulfide. This one would be lithium bromide. Magnesium nitride. And then we have calcium fluoride. Okay, for the rest of these, what's going to happen is that I'm going to give you a name and you're going to write a formula. So for this, you're actually going to have access to a periodic table, and you have to look at what the representative charges are. Basically, you look at what charge each of these elements has when it forms a compound, and then you cross the charges. So you look at barium. Barium on the periodic table has a charge of 2 plus. Nitrogen, you'll notice, has a charge of 3 minus. So what happens? I write them like this. I'm going to write my cation followed by my anion, and just the numeric portion. The 2 comes down here, and the 3 comes down here. I don't put the plus and the minus because the plus and minus just tells you which thing comes first, which thing's the metal, which thing is losing electrons, and then the minus tells you what thing is the nonmetal, what thing is gaining the electrons. So don't put the charges down below as subscripts, you just put the numeric part. So Ba3, N2. Indium fluoride. So I look up indium. Indium has a charge of 3 plus. Fluorine is always 1 minus. And so the number 3 comes down here. This 1 goes here. The 1 is understood, so you just write it INF3. Calcium oxide. I look up calcium on my table. It's 2 plus. Oxygen's always 2 minus, CaO. Okay, and this 2 comes here, and this 2 comes here. Notice they are equal and opposite. They cancel or they reduce. You must reduce them. So calcium oxide would be CaO. Sodium nitride. Sodium is always 1 plus. Nitrogen is 3 minus. So this 1 goes there, which is understood. This 3 goes here. So it should be Na3N. Magnesium chloride. Magnesium is always 2 plus. Chlorine is always 1 minus. 2 goes there. MgCl2. Potassium oxide. Potassium is 1 plus. Oxygen is always 2 minus. 2 goes down here, so it's K2O. Magnesium oxide, you have magnesium, which is 2 plus. Oxygen, which is 2 minus, equal and opposite, they cancel. It's just MgO. Potassium sulfide, potassium is always 1 plus. Sulfur is always 2 minus. K2S. Lithium nitride. Lithium is always 1 plus. Nitrogen is always 3 minus. Li3N. Strontium fluoride. Strontium is always 2 plus. Fluorine is always 1 minus. SrF2. Aluminum sulfide. Aluminum is always 3 plus. Sulfur is 2 minus. Al2S3. 3 goes there, 2 goes there. We cross them. Calcium oxide. Calcium is 2 plus. Oxygen is 2 minus. They're equal and opposite. They reduce. CaO. And that's it for the first page.